Hi there, we are going to look at some polynomials today, and we are looking at like and unlike terms. This is one of those key things that, students just gloss over, or they know the definition, what a like term is, but they don't understand it. They just memorized it because somebody somewhere told them that. So today I want to give you that deep knowledge that's going to make sense, and it's going to be, oh, that's why that works that way. So like terms, really simple. There it is. They have to have the same variable and the same exponent. And the coefficients out front don't have to match. Don't care about the numbers out front. So let me just highlight this. This part is the part that has to be matchy-matchy. Okay, so if I want another one of those, I can have 5c to the 7. I can have c to the 7 over 2. I can have minus 6.8 c7. It's all good as long as there's a c7 in each and every one of those. They are all considered to be like terms. The moment you put a d in there or you change that little exponent to something else, they're not like terms anymore. I did some pre-done examples for you. Look at that. 6x, 7x, minus 2x. They all have x's. Now, little hint here. You can think of them as either they don't have an exponent, but in truth, there's a little bitty understood one on all of them. Nobody bothers writing it because it's the most common version, and somewhere along the line, the mathematicians just said, nah, that's always like that. What's the point? Kind of like, when you're talking about, well, let's say temperature in Saskatchewan. Yeah, it's 20. Unless it's the wintertime, everybody just assumes it's a positive. And this is the same. You just assume it's a 1 up there. Now we've got negative 3d to the 4th, and d to the 4th, and d to the 12, d to the 4th. The exponent is the same every single time. The exponent, so it's a d, and it's a superscript 4. So we're golden. Right? And we got a squared here. I don't have to care whether it's a fraction out front or it's a decimal. It's all good. Same thing here, we got a whole bunch of t's. Notice here at the end, there's even a t all by itself. Doesn't matter, it's all good, all the same. We've got AC and 5AC and minus 10AC. Those are all like terms because they all have A's and C's, and they're all to the first power. I'm hoping at this point, this is already making sense. You should maybe turn off the video now. Take a look at this next part with unlike terms. Explain to me or to yourself why they are not like terms. And then maybe, I don't know, pick out the first one or something and write some like terms. That makes sense? All right, turn off the video, give it a shot. Okay, I'm gonna trust that you did that. So this is just completely messy because we got an x, we got a t, we got an e. The variables are not the same. Right, and the definition says it has to have the same variable. So not same variable. So if we go start with 5x, 10x, 15x, 20x, doesn't really matter what you write there as long as there's set of like terms. You could put like t's in there and you could have like 5, 6, 8 t, whatever. Just as long as you understand what you're doing. All right, we got minus 6t. See, look, this one looks better. They're all t's, but what's the screw up? Okay, not matching exponents. So not same exponent. You have to have the double match. It has to be the same letter and the same exponent. So minus 6t squared, I'll use that as my first one. T squared, 5t squared, minus 456.8 t squared. Doesn't really matter. As long as there's a t squared, it's going to be a like term. Now, what's wrong with this one? It looks pretty good. Okay, the fact that there's a negative 4 out in front of all of them doesn't really mean a whole bunch in this question because the part I didn't bold up there, coefficients out front don't have to match. If they do, good. If not, I don't care. Like terms have nothing to do with coefficients. But look, we've got squared and cubed and to the 5th power. So not same exponent. I was trying to trick you up there. So minus 4y squared, 7y squared, 13y squared, whatever. That would be a set of like terms. All right, you got this. But I want it to be, you see, I want it to be here for you. I want you to not just I memorized. I want you to understand. It's not that complicated, but if you've never taken the time to learn it, or maybe the day they went over it in school, you were gone or busy or whatever, I want it to be there for you now. Some of you are ranting. I want you to understand this. This is so important. And it's kind of straightforward once you see a bunch of examples. Okay, and there's no pressure. If you don't get it, rewind the video, watch it again. If you still don't get it, if you know me, email me, we'll explain it, or find another video, or ask your best friend. Ask a random stranger on the bus, could start a really cool conversation. Anyway, I'm ranting. Let's get back to this. So we need to circle like terms. So we're looking for stuff that has the same letter and the same exponent. Okay, well, this is not really challenging. There's an X, and there's an X. Ta-da. Okay, if you haven't done it, turn off the camera, do the rest of them. And I trust you did that. All right, next one. Sneaky. I'm not even sure I did this right, but I'm going to say that that's a like term. And that's a like term. Those are really constants, which is a fancy word for just like a number without a variable on it. It's called a constant because it's the same value every day. Whereas if you put a letter there, it can change from day to day. All right, let's see. We got, oh, there's a T, there's another T. Oh, there's more. There's lots of T's there. Those are all like terms. And we've got two, let's see, quick look. Those are all R's, that's good. So the variable is the same, but my exponent, this one's a 4, and this one's a 4, right? We're looking at the little numbers. There we've got the matchy-matchy stuff going on. We've got R to the 3, 5T to the 3, 5Y to the 3, and R to the 3. So there's 1, and there's 1. C, 3P, oh, R2, D2. Okay, I was trying to be funny. What matches? Nothing. No match. No matches. Oops, M-A-T-C-H. Sometimes I do that just to be tricky. Not making a mess, but getting one that doesn't have a solution. All right, I want to review this last part here. This is from the previous video. If you did not watch the previous video and you don't understand this, you should go find the previous video and give it a shot. Okay, so review. 1, 2, 3, 4, 5, 6, 7. So I've got P's and they're multiplying and there's 7 of them. It's as simple as that. Now here we've got 1, 2, 3, 4, 5, 6. Oh, look, there's 7 of them. We got AP, but because this is addition, the 7 goes out in front. If that was all multiplication, oh, I'm tired of writing so many. Then you would have AP, and we put it in brackets, to the 4th power. We need brackets because if you wrote AP4, that would just be A times P times P times P times P. Okay, so brackets are important here. Now, ooh, this is weird. Look at that. We got some R's. So there's 1, 2, 3 R's. Now we're adding, so that makes it like this. And then we have 3 T's plus 3T. You really can't smush them together because they're not like terms. So you can't. Whoops. That's the next video on addition. But for now, that's what that stands for now. 5T squared. That means T squared plus t squared. How many think? Yeah, no kidding. It should be 5. 1, 2, 3, 4, 5. Okay, that looks after this. And then each one of these is actually t times t. One, 2, 3, 4, 5. Now, if anybody's worried, if you want, you can put brackets on both. It doesn't matter either way, whether you have that front one in a bracket or not, because this letter is right beside that with some brackets in there. That means multiplication. So if you take 5t squared and expand it as much as you can, you get t times t plus t times t plus t times t plus t times t plus t times t. And that's why this is a beautiful shortcut. Math is cool.